So where is the breath born? Many people think and consider that carbon dioxide is the primary stimulus to breathe, and that oxygen is also one of the reasons why that we're breathing. That's not particularly the truth. Now, I'm not saying that carbon dioxide and oxygen levels don't affect how we breathe at all. What I'm saying is the origin of our breath is not information received and coming back from our chemoreceptor. In this session, what we're going to delve into, we are going to look at where the breath is born. We're going to have a look at the anatomy of some of our respiratory system before we dive into this. So what you can see is we essentially have a nose and a mouth. We can breathe through either one of these. The arguments are that nasal breathing is much more effective and efficient and more healthy than mouth breathing. However, the air can travel both ways into trachea. It goes from our trachea, passes through to the bronchioles and the bronchi. And those are like the branches of the tree into the lung, you could say. This area does not take up gas exchange. So there's no oxygen being transferred here, no CO2 being transferred. It's simply a tunneling process down to what we'd call the alveoli. The alveoli are very small sacs. There's millions and millions of them. In fact, if we were to lay the surface area out of our lungs, the alveoli size would probably be about half the size of a tennis court. And it's that large surface area that allows for a massive amount of gas exchange to occur, that allows for the oxygen to get inside body. You can see we have obviously two lung lobes, the right and the left. The right lung is split into three sections, so an upper, middle, and lower lobe. Can you think of any reason to why that might be? I'll come back to that in a moment, just while you're thinking. On the left-hand side, we can see we've got two lobes. And the left side of the lung will have the heart encased behind. Underneath, we have this diaphragm. Diaphragm is a very interesting muscle because it's both a unconscious muscle as well as a skeletal muscle that is, we can actually have active control of it. And it's the only skeletal muscle that really has a role in being an organ, we could say. Diaphragm comprises of roughly 50-50% type 1 and type 2 muscle fibers, meaning that it has good strength, but also it's built for endurance. Of course, we have to use it every single day, every single moment of our life. And it's connected to our rib cage all the way around to the base of the spine. And essentially, it is this movement of this diaphragm that allows for the change in pressures and volumes in our lungs so that we can inhale and exhale. However, where's the breath born? Is it the nose? Is it the diaphragm? No. The breath is actually born in an area called the medulla oblongata. In particular, we have a group of what we call central pattern generators. And these central pattern generators don't require anything of feedback just yet to create their own impulse. So just like inside your heart, in your heart we have something called a sinoatrial node. It has its own electrical impulse that allows the heart to contract. In our medulla oblongata, we have something called the preBötzinger complex. And that preBötzinger complex was discovered by Jack Feldman at UCLA over in America. And essentially it has its own way to create an electrical impulse and to utilize energy to create a potential, which is the basically shifting of ions in the cells to create a charge. So the charge can then be sent as an impulse down the phrenic nerve, and that phrenic nerve is what then causes the diaphragm to contract. So our phrenic nerve is typically between C2 and C4 of our spinal cord, and it will go all the way down and innervate at the external intercostal muscles and into the diaphragm. And therefore, when we get depolarization of that, we get an electrical impulse sent down the neurons to create a contraction, which then changes the volume of our lungs, which then creates a negative pressure, so air comes in, we get an inhalation. So the preBötzinger complex is generating what we call a pattern of our inspiration. However, when we inspire, at the very top, it's very important that we don't overinflate our lungs. And in fact, we want to slow the breath down so then when it comes back in, it doesn't crush on the exhale. So we have this collar fuse nucleus here. And within there, we've actually got a reflex that's been argued whether it occurs at rest or whether it's just during exercise, but particularly when we get to a larger lung volume, we get what's called the Heron-Brewer reflex, and that reflex is mediated by our vagus nerve, and that then causes our lungs to slow down, our diaphragm to slow its speed down, so we can have this passive kind of, end inspiration. So a post-inspiratory phase, and then at rest, expiratory phase, It's just simply a squeezing pump motion and elastic recoil from our lungs, and therefore our exhale is passive. So when we're resting, typically an inhale to exhale ratio is about a 1-to-2 ratio, because the diaphragm itself contracts. So the inhale, the respiratory drive is quite forceful. We have a faster inhale, and then because of the passive exhale, the relationship between the inhale to exhale is roughly 1-to-2. But when we start to exercise, particularly when we get into moderate intensity exercise, or when we were in REM sleep, or if we were to go to altitude, we would then start to get a shift in what's going on here. What we now get is a part of the brain called the parafacial nucleus, which is in the ventral respiratory group. It's still in the medulla oblongata. However, this parafacial nucleus now switches on to have its own depolarization, and it allows for an active exhalation. So then, therefore, our rectus abdominis and our internal intercostal muscles will become active to generate a more forceful exhale to allow us to offload more CO2, but also to be able to generate, when an exhale compresses, the next inhale has more ability to rebound back with our rib cage to inflate the lungs easier. So this circuitry is very intricate, and you can see there's a connection between all of it, with the preBötzinger complex creating inspiration, the fused nucleus creating the passive exhalation, the post-inspiration, and the parafacial nucleus having this exhalation focus, with the Bötzinger complex controlling the mechanism of all of these. So these is where the breath is born. This is an area within our brain, particularly in our brainstem, that's very primitive. In fact, that we can have people who are in vegetative states, who are still breathing on these patterns, and maybe they have no change in their metabolic system, but they will continue to keep at a consistent rate. Just like going for a walk. Any behavior that is so clearly necessary for survival essentially is run by what we call a passion generator, and this is what this area is. So this is where the breath is born. So the breath is born through electric charge. Hope you enjoyed this little session, short breakdown on physiology. I enjoy these little sessions here, giving you a bit of information, going a little bit deeper into the breath science to take some nuggets away so you can understand the nature of breathing and the impact it has. If you enjoyed this actual conversation, if you have any questions, drop a comment below, give us a subscribe, and we'll have another session out for you soon.